Hey guys, welcome to part 2 of the notes on section 10.3. So hopefully you watched part 1. We left off here on example number 3. So a little illustration of the power property. Oops, wrong one. So I'm going to show you one more example of that. So the point or the thing to learn here is this. If you are starting off with example, they're asking us to find log base 3 of 1 over 49. And the given information has a 7 in it. Somehow I got to work a 7 into this problem. So 1 over 49. Well, what's another way I could write that? Well, 7 squared is 49. So now I got a 7 in the problem. That's helping because in the directions it said something about that. Directions says log base 3 of 7. I currently have a 1 over 7. Not quite the same. So it's been a long ways back. But somewhere in the past, we talked about negative exponents. Negative exponent means I'm supposed to move it to the bottom. Well, if it was already in the bottom to start with, and I don't want it there, I can reverse that process. Now I got a 7 in the negative second power. So 7 in the negative second and 1 over 7 squared, same exact thing. But the key is I now have a 7 in my problem. Power property. Here's how it works. I am allowed to take an exponent that's within a log problem, and I'm allowed to yank him right out in front and make it into a multiplication problem. Crazy? A little bit. In the directions, it tells you what log. Left the base number off here. Sorry about that. In the directions, it tells you what log base 3 of 7 is, or approximately is. It tells you it's 1.7712. And finally, I've rid myself of all those nasty logs and nasty fractions in that problem, and I finally get to pick up a calculator and type in -2 times 1.7712 to finalize that problem. And I've got -3.5424. So illustration of the power property. But again, here's the key. Here's what you need to know. Anytime you have an exponent within a log problem, you get to jump that guy out in front and make him into multiplication. So the exponent's gone, makes the problem a little bit easier. All right, we're going to start the equation solving down here. I'm going to do this first problem, and I'm going to save the other two for part 3 of the videos. So definitely check that out. So we'll get 1 in here. So what we're trying to get you to realize is this. If I start off with some multiplication problem, there was a 3 times 16 in one of the previous problems. Multiplication gets converted into add. Divide can be converted into subtract. Those are properties, log properties. So let me go back up here. This is all the stuff we did from the previous video, and point out to you this guy. So you can go opposite way as well. If you're given a problem that has a plus sign, then you can go backwards and make it into multiplication. If you're given a problem that has a subtract sign, you can go backwards and make it into a division problem. So take a look at this first one. It's got a subtract. So at some point I'm going to work division in. But I'm also going to do the power property. This guy's out in front. If you remember in the last video, we took the guy that was inside the exponent and yanked him out in front. If I'm solving an equation, think about it. Equations, you're working backwards. If I got a -7, I do +7 to get rid of it. If I got 4 times x, I divide by 4 to get rid of it. So I'm going to go backwards. I'm going to put that 3 back in there. All right, speaking of backwards, a couple problems ago in that previous video, part 1, we took a division problem and split it up into subtract. Well, equation solving is going the opposite way. We're working backwards. So if I have a subtract problem, I want to make it into a division problem. There's the first argument. There's the second argument. Now you're probably saying to yourself, why in the heck is this helpful? That's sort of crazy to do that. But I would point out to you this. Look in the previous line right here. How many logs do you see? Count them up. 1, 2, 3. If we use the quotient property, how many logs do you see now? 2. It's better. You got to at least agree with me on that. All right, back to section 2. Good news. Equality property. You got a pair of log base 5s on either side, you get to hack those out of there. Here's what's left on the left. Here's what's left on the right. And you are finally back to what I would deem a normal problem. No more logs, no more craziness, no exponents. Well, we do have an x to the third, but solve like normal. How do you get rid of a divide by 4? You multiply by 4. How do you get rid of a cubed? We did talk about this earlier this year. You cube root it. Pick up a calculator. It will tell you the cube root of 64 is 4. All right, I think I have time to do number 6 here, so we're going to go ahead and try at any rate. All right, notice on this one, it does not have any numbers out in front. Nothing out in front here, nothing out in front there. So I don't have to do the power property, but I do have a plus sign. And if I have a plus sign, they're asking to do the product property. So take a multiplication problem, split it up into add. Take an add problem, rewrite it as multiplication. So first argument times second argument. So, well, what do you got here? You got 1 log. I don't get to cross off logs on both sides like the last problem. Boo-hoo, life stuff. What else did we learn in chapter 10? We learned that there's such a thing called exponential form. And if you get stuck with a log, you're supposed to think about exponential form. That's the base. That's the exponent. This guy's the argument. I'm going to multiply him out. So all I did was the distributed property right there, just trying to save a little bit of time. Where'd the log go? It's gone. That's what exponential does for you. So 2 ways to get rid of a log. Go back to number 5 over here. Have a log on both sides. You get to cancel them out. Gone. Have only 1 log. You can convert it into exponential. Gone. Remember chapter 5? Chapter 5 was quadratic equations. Quadratic equations, you were supposed to get 0 on the end. If you're in honors class, you can pick up your calculator and run your calc program. If you're not, you might have to do this. When in doubt, factor it out. X and X. 8 and 2 to get 16. I want to get a negative 6 in the middle. That's what my signs would have to be. Switch the signs for your final answer. And we're pretty nearly done. Hey, what's always a good idea? Check your answers. You're right. I don't make up with the rules of math, ladies and gentlemen. I report them to you. For these guys, we learned in the previous section, you're supposed to check. So if I were to plug the 8 back into the original problem, I'm going clear up here. I plug an 8 in there. 8 minus 6 is 2. Log base 4 of positive 2. Arguments are allowed to be positive. If I plug an 8 right here, that would say log base 4 of 8. Positive, allowed to do it. But what happens if I plug a negative 2 right here, guys? It would say log base 4 of negative 2. And it's impossible to do a negative argument. I don't make up the rules. So this guy, impossible. He's called an extraneous solution. We did him correctly, but he's not going to work. So final answer to this guy is just the 8. All right, there was one more problem for this section. There is a part 3 to this section's video. Play it if you want. Thanks for watching.